Alright, guys, I'm gonna be doing another meta tagged problems from Leetcode with a variant. The goal is to finish it in 20 minutes with the dry run and the variation, along with like any code improvements and debugging that whatever would be needed. So let's get started. I'm gonna start the timer once I face the question. And right now, since I've seen the question before, obviously, I cannot mimic the interview setting, but I'm gonna still like just write the questions and think of of the follow-ups that I will have once the question has been pasted. All right, so we paste this question and let's start a timer for maybe 22 minutes because it's a bigger problem this time. All right, so here we're given a string s of open bracket, close bracket, and lowercase English characters. Okay. Your task is to remove the minimum number of parentheses in any position so that the resulting parentheses string is valid and return any valid string. Okay, so our input, it's a string, and input is also a string with removing the brackets. All right. Then my question would be, since it's a string, so white spaces, then input characters. So is it like alphabets, alphabets, and new digits? Anything else that we need to worry about? But I think that would be it. And length of the string, and yeah, is there like any other brackets? All right, so right now, white spaces, no. Input characters, alphabets, yes. Digits, no. I mean, it could be there. And length of string would be somewhere around from 1 to, let's say, 10 to the power of 5. So this kind of removes the edge case if it was this, right? But one follow-up to that would be, what if there is a string which is like this? So I think we have to return an empty string, right? Because this does not have a matching bracket, so that would be one edge case. And are there any other brackets? Not as of right now. All right. So let's think of an example. These would be all the questions. We could maybe do interview, interview, right? And here, maybe this is the S input. Right now, we're not dealing with like any gaps. Okay. Since we are returning the string, we know that it cannot be modified in the answer itself because it's immutable. So we will have to have like an answer string, right? So in this case, we see that there is an additional open bracket and only one. So our output would be this string, but without either this opening bracket or this opening bracket. So either one should be fine. Or this, actually, let me just write that. So this or this. So it could be either answer. One question I would ask is, mm, where did it go? All outputs or just one? One for now. All right. And we move forward. One question would be, what if like this was the thing and there was additional? So right now we have one, two open, two open. What if there was additional like brackets? So again, we have to remove either one or this one. So whichever is middle. Okay. So in this scenario, when say output, it would be this one. So either we can remove this one or we can remove this one. So we have one, two, one, two. Yeah. Oh, did I do the same one? Lol. Actually, this one. And then now we can have this. Yeah. Okay, one approach could be like use a stack. Um, so in the stack we add INTER, all good. Now we can add like one open bracket, good. Actually, we can just process the string, right? Like and append it in our answer. So it could be INTER till that, and now we append only the open bracket in the stack. Right now, open count is just one, right? So we can just add that in the string as well. We add YEW and also this. Now we have two, so we need at least two closing brackets. Two closing brackets. So we have added VIE, and for this example, now we saw closing brackets, so we can decrement the count one. And then we don't really need the stack if we think about it. One way is either just add everything in the stack and check for brackets at the top. So, um, so I don't think we need that in this solution, but also if we use stack, this would be O of n, memory wise. Memory wise, as we're using like we can store every element in the stack. Other approach could be just using the open count and close down solution. Actually, we only need the open count, right? So once we go forward with this solution, let's say there was an additional, so we can have like a result, and then we will add from here INTER, we add open, so our open count increased by one. And now VIE, VIE, we add open count, so that is also two. Now we see this, and now we decrement the open count by one. Now we have only one unmatched W, so W. So right now we also have this left. So maybe we can like pop either one, right? Like I don't know which one to pop, so we have to go over the result to take care of that. But what if like we had additional INTER? Like in this case, we have additional closing brackets. So INTER, we add VI. So this would be open count equals one for now. TER, now we add VIE. we add both. So this became 1, right? Because we added this. Oh, right. We added this. Now we had 1 more. So now, and then this becomes 0. And then now, since this is 0, we can skip this last character. So I think for the first pass, we check and remove all the open brackets. And for the second pass, we can check for all the close brackets. Here, the time complexity would be somewhere around O of n. So first to pass, first pass, like we go over the string entirely to remove open brackets. So O of n, that is the length of the string, and then second pass we go over the string. It could be halfway or it could be worst case scenario all the way. So O of n, so would be 2n, which would anyway be n. And space would also be O of n. Again, same logic for res, and then we have to like iterate over final res, right? So that would be 2n, which would reduce to O of n. All right, I can go ahead and implement this solution. All right, 4 minutes, not bad. Explain, define, remove parentheses, I guess. Parentheses, and I could do like classes and stuff, but maybe next time. Input is a string. Is that the name of string? Yep. Also, I did not realize like if this was already given, I should not have that asked like a bunch of questions here. But anyway, okay. So it's a string, and we are also returning a string. Okay. We need final sorry, result, which is just this, and then we need open count equals this 0. Okay, actually, we will also see like total open, right? So at the end, when we are trying to remove extra open, then we can decrement it accordingly and remove it. And we can also do maybe an early exit, because at that point we'll know how many are left after all of the closed conditions are satisfied. All right. So we do for character in S. So if character equals maybe an open bracket, then we can increase the count. Open count plus equals 1, and sorry, total open equals 1. And we also append it to the answer equals 1. Otherwise, it would be character, which would be equal to this. Then we do open count minus equals 1, and we append this. And then if open count is bigger, right, like than 0, then actually maybe just if it's equal to 0, you just continue, don't do anything. Otherwise, just add the character res plus equals character. Okay, so we take that, and otherwise, if it's any other character, right, except that one, then we add, like it could be the letters, so plus equals character. So take take care of open brackets. Sorry, close brackets. Skips extra. Skips extra. Now, what we can do is final res would be another string, and we have to take care of additional brackets, open brackets. So let's say how many should we keep? So that could be like total open minus whatever was in the open count. How many open brackets to keep? All right. And we will eventually be returning the final result. And here we go over for character in res because that's where we added everything. Then check, right? Like we add every character. So final res plus equals character. But if this is like 0, then we don't need to add the. So we don't need to add that. So if character equals open and the keep is equal to 0, then just continue. Don't add anything. And then yeah, that's what we'd be returning. And then yeah, this should be good. Let's do a quick dry run. So let's say we do it on this example. Interview. Okay. Here. Okay. Okay. If this is our string, let's say we add, right now we have extra closing open, right? So this and maybe one we can add here. So for character, and let's do this. So this is what our initial result is like. And we start here. So it's for character in s. If character is equal to no, this, no, continue. Okay, when we are here, so just append it to the answer. I move the character. This for loops goes to next C, and now do we have, again, this condition executes. Now we are here. So at this point, we will increase our open count to 1, and we also increase our open count to 1. And then here, actually, there was one more case, edge case. What if it was this, right? Like initially there's like just 0. So this condition, if open count is equal to 0, you just continue. So eventually this would have like just been skipped. That's the core lot, like one edge case that I forgot to mention earlier, but I think like this code would take care of it. So yeah, n is good. Now we are at this open bracket. So this condition. Oh, yeah, we did not add n here. And then our open count is 2, total open is 2. We move forward till ER. So DER, we added that, and then this is 3 right now, this is also 3. Now we come to VIE, so this is what it'll take, VIE, and then we add one more. So right now our total count is 4. Oh my, let's add one more. I don't give extra. And maybe one here. Right. So that will take care of the logic. Okay, so VIE, we add this. Okay, so we have 1, 2, 3. 1, 2, 3. How did I get to 4? Actually, this is what fourth one was. Right, and now the character here would be here. So if this is the character, then we will decrement our open count by 1, so that becomes 3. We are good, and then we will append this character because it's all good here. W would be appended. Now we are at this character, so this would be appended again, and the count would decrease to 2. And where did we go? Here. So now here the open count would become 1, and we would append this character. And here finally the count becomes 0. So we cannot add this, and we will continue here. Same for this, it's still equals to 0, and this is the character we are at. And now our open count becomes 1 again because we have to add, and this is 5. And now we will append this to our answer. Okay, so here we have additional open count. So now the final result would be this, and final res is, oh, I did not decrease the count, right? So keep minus equals 1 because we'll see in the logic right now. So final result is empty, and then we are gonna go over this string, sorry, this string here, result string. Oh my, it's 20 minutes. But let's finish this dry run and I'll do like a variant in another video. Okay, so we start here. This is where the character is. And in the final result, we will, this is not equal to this, and actually keep is 5 minus 1, which is equal to 4. We have to keep 4 open. So this is good. Right now, keep is not equal to 0, so we will add this in our final. This, then we add INTER. Actually, then our keep would be minus 1, right? Because we added this 1. So we right now the keep is at 3. So we have added this. Now we see another character. So this keep should go inside this. So this would be, so if this is the case, and x character is equal to this, and if keep equals 0. Yeah, if keep is equal to 0, then we continue. So where were we? DER, right now we are here. We come here, and then we see another one, so this becomes 2. Yet we add this. This part is good, W is good. We do this and this. This part here is all good. We are just gonna actually this, and else if that is the case, then like decrement it. Okay, and at this final count, so we add this, we have made it 0 here, we have added all, and now this is the extra one, right? So in the final result, we don't want that. If keep is 0, you just continue. I think I messed up in this logic. Let me just check it very quickly. Here, this would be character, right? Not one. And also, if open count is greater than 0, so this condition would execute and make it negative. So have to take care. So if open count is greater than 0, then you go ahead and decrement it. And you also do like add it to the character. And avoid, so avoid making open count negative. And then here, and we don't really need this, right? Because we'll only add it if it's greater than 0, so plus equals character. Else we have reached where it would be this. This would be like skipping extra character. And then here you if character. So first we just check if character equals this, and if keep is greater than 0, then we add it to the answer, right? So then final res plus equals character and decrement the keep count. And then otherwise just append it because that's what we have left. And then return the final. So I think the code is fixed. It could be a little cleaned up, but it's already over time. So thanks for watching.